So good morning, everybody. Thanks for. I'm sitting right now for the camera. uh, Thanks for the kind words of introduction, and especially thanks for the initiation of this symposium to Felipe and for the organization by Irene. I want to, in my talk, I want to address diversity, the topic of diversity, and what I mean by diversity or by diversification. That is that in forest stands we can promote the variation of structure, the variation of genotypes, and the variation of species. And when we do that, when we promote the variation, then we can maybe trigger ecological functions and services which are better than in monospecific stands. In this way, might become possible to integrate functions and services into the normal forest management, so that maybe it is possible not to set aside huge areas of the landscape without any measurement, something like a museum, and on the other hand to have very intensive plantations, but to integrate, as people are living on this landscape and they want to enter the forest, and they maybe also should be aware that there is some operation, some usage of the forest. So the talk is regarding the diversification and integration, and that is something which is not only happening in forestry, but in all kinds of institutions. For example, at the Technical University, we have a board of diversification that tries, for example, to improve the age class structure in the faculty or in the university, the gender balance, the internationality, in order to improve the efficiency and the sustainability of the team. So that when I talk about diversification in forests, that is interesting, but I mean that in principle that is going on in universities, in enterprises, in schools, that we learn more and more that diversification can mean stabilization and increase of stability and sustainability. Yeah, and the title here with this long list of people under the title that is near the length of an abstract. The background is that Felipe and me had an initiative for starting that is called Unleashing the Potential of Diversity of Structure and Species for Integrative Forest Ecosystem Management. And this included people from Bolzano University, from Wageningen, from Buenos Aires University, and some other people. And that is the reason why there is such a long list. And I will just talk about the forest perspective. So there are also urban scientists and agriculturalists, but my talk is about forestry and diversification in forestry. And forestry, the history of forestry is more or less not the history of diversification, but that is a history of separation, of segregation, of homogenization. And what you see here on the first slide, I'm used always to look to the screen. That is the typical effect of human impact in the Middle Age, that we separated the landscape into urban areas, into agricultural areas, and into forest areas. So from the beginning on, there was a segregation of the landscape. And in some areas, in the forest area, the wood productivity was the main ambition. You see here a photo of Karl von Karlowitz, who founded the idea or invented that principle of sustainability. And book Silvicultura Economica, there he mainly addresses wood, the wood as main product of forest management. And in order to improve the wood production, they, in those times, they divided the forest in management blocks. And these management blocks consist of even age stands that was easier to manage the forest productivity and the growth and yield by even age stands, and cut one and establish one. So that means the whole procedure of management was very easy to do regarding forest, regarding wood, if you have monospecific stands. So the whole development was not towards diversity, but towards homogenization, focus on wood and monospecific stand age class forest, as that is easy to manage and easy to keep sustainable. But now you see that even the forest scientists of today, for example, here this candidate that is a speaker of today at the age of 2 years, and they were socialized in monospecific stands. So I'm playing there with my older brothers, and that is a typical post-war stand of spruce, and you see wood was the main product, homogeneous, and now came the interests and the demands of present forest management. Today we want maintenance of forest structure, carbon stock, health and vitality, forest growth, biological diversity, protective functions, socio-economical functions, health, income, recreation, and so on. So the original concept of sustainability focused on wood production now suddenly is extending to all kinds of different products. And of course, the monospecific stands in the past, which you see here, they cannot fulfill all these demands. You know well, this acid rain, the storm, the bark beetle, the drought effects in Germany, and all these disasters were much bigger or much severe in monospecific stands compared to diverse stands. And fortunately, some pioneers of forestry very early established already 50, 100 years ago, always had some ideas to go towards more complex stands. So in extreme cases, that is the step from even age stands, these typical monocultures, to selection forests, where you have 2, 3, 4 species, uneven aged, all maybe monospecific stands, but with different tree sizes, and that could be in some cases a diversification of structure. So that is a typical age class forest, that you have plots of one age, of another age. So some pioneers already some decades ago, they moved to stands which are still monospecific, but with different age structure, and in other cases mixed species forest stands with different age structure. So that is the extreme, and forest management uses to go from one extreme to the other in many cases. But there are also other possibilities to create mosaics, and that is to stay in the stand level, but to have stripes of different species, or to frame one species by other species. And all these diversified stands, where we have some examples, a couple of examples show, and that, for example, some of these forest ecosystem services and functions, such as biodiversity, can be improved by structural diversity. So, for example, if we have stands where not every tree is 20 centimeters in dBH, but where we have a variation, then the diversity of animals and plants in that stand increases in a logistic way. This diversification can also have an effect on the survival probability of the trees. For example, if we mix, we increase the survival probability by 20 to 40%. Very important, for example, in mixed stands, results from our EU projects, that is, in many cases, you can mix, and if there comes a drought year, then the mixture can have the effect that the trees, they still suffer, that is clear, but they suffer less. Not always, but there are many cases where one tree pumps, for example, the water up, and the other species can live better, as it has a better water supply. So there can be, by this diversification or mixing or structural mosaic, there can be advantages regarding the ecosystem forests and services and functions like biodiversity and vitality, but also regarding the classical forest services like wood production. So there are examples that you have one species. Yesterday we visited some of these stands where you have a monospecific stand that produces a special amount of wood and another monospecific stand, and if you mix two species, then you have a plus of 10 or 20 or 30%. And that is very important, as that in this case you don't need fertilizer, or you don't need permanent tending, but you only need brain. I mean, that you know, or visit some lectures, that you know that if you mix two species, you have an advantage. There are also other examples where there is a disadvantage, of course. So it's possible to increase the productivity by, for example, by mixing or structuring. It is possible to increase the carbon stock. And if you, for example, mix 1, 2, 3, 4, 5 species, there can be an increase in productivity, and it's not so clear if more diversity, for example, in the forest, but also in other systems, increases all along the x-axis, or whether there is maybe a decrease, so that it is a unimodal relationship. That can be, but we do not have many examples of that. So there are evaluations which suggest that maybe there is also, regarding the diversity, an optimum in the middle. So having a middle, a medium diversity. So what I want to say with that is, if you diversify by creating structure or mixtures or mosaics, it can be possible to integrate different functions in forest management. So like recreation or biodiversity, so that you put all in one box and you avoid maybe this segregation between museums and high-intensive forest management. And as an example, that is this my Spanish teacher told me that that is the Castillo del Rey Loco, called in Germany. That is the castle our last king in Bavaria built, with central heating and so on. But I don't show that for that purpose, but for the purpose you see here, landscape. When all these hundreds of Chinese or thousands, are entering this castle as tourists, they can hear the chainsaw in the background, as there is also forest management in this district. There is a lake that is the Lago de Cisne, as the king liked the swans, and there are people swimming here, and there are woodworkers, and there are tourists hiking, and there are people skiing. So that means that is a typical example where you have an integrative forest management. So that is not a museum, but that is a living part, and the people, the tourists, they like, when they go to that castle, to see the cows passing the trails, or to see a harvester, for example, as that is interesting to have this combination, and then you have a living landscape. So I summarize the first part of my talk. There will be 3 summaries. Sorry, Felipe. I summarize the first part. The extended demands for ecosystem services and functions are not achieved by artificial monocultures. diversification of structure and species can enrich ecosystem functions and services. Diversification supports integrative forest ecosystem management. So if we realize that and we want now to push this diversification, I mean not as we discussed yesterday from the scratch that you say, okay, I design now a complete new landscape, but if you want to say I have an existing landscape and I want to promote here a little bit and there a little bit the diversification in order to improve the ecosystem services and functions, then you in principle need, or I think then it's impossible to have data, I mean knowledge, which species with which other species or which structure with another structure triggers some emergent properties. You need models to do some simulation runs to analyze what is happening if I do this or that, and you need somehow training and teaching and model examples. And the first thing is the knowledge. So and that is one problem, as the knowledge we achieved in forest science is mainly based on monospecific stands. I would guess that if we summarize what we worked about which kind of forest stands we worked so far in the last 150, 200 years, that is probably 95% monospecific stands. And that means if we now have the idea to establish mixtures or structured forests, then presently we only have the chance to use inventory data or, for example, temporary plots, as there are only very, very few long-term experiments with mixtures existing. And that is the reason why we had these huge EU projects together with your university and others, that we established, for example, throughout whole Europe, such triplets. As there are no long-term experiments existing, and then by establishing this, then we know monospecific pine, monospecific beech, what is the mixture producing. And not only here in Spain, but reaching from Spain to Lithuania and reaching from France to Bulgaria. And several of such transects we established. And that long-term experiments would be much better than you have ceteris paribus situation. You know where the effects come from, and these forest inventory data or triplets, they enable a correlation, but not a real mechanistic explanation. So on the long, we need long-term plots, and so long-term experiments. I will not go into detail, but Enno will today present in the poster details about these new kind of mixing experiments, which are now established throughout several European countries in order to get ceteris paribus conditions. The second thing we need are models. Models are normally used in forest management mainly for two things: to derive silvicultural prescriptions, so how to thin, how to space stands, and to calculate what is the best option, and to calculate the annual cut. So how many cubic meters can I cut per year and hectare in order to not destroy the sustainability. And such models, if we want to have all these nice functions and services, we need models which are spatially explicit, so where you can read in data not just the mean value of a stem, but you need it should be possible to read in such a model spatial structures, so that you can say, okay, monospecific, group structure, gap structure. And it is important that as output values you get not only productivity in terms of cubic meter cubic meter or carbon, but there should be all these, so biodiversity, aesthetics, and so on, that should be included. So that means we need new kinds of models, and very luckily such models are existing. So for example, in Philippe's groups, they developed excellent models which can do that. But the problem is that so far we need data for parameterization, as we have simply a lack of data of different mixtures, and data which show us the mixing effect. So what will happen if we mix Pinus halepensis with Pinus silvestris, for example? So if we want to model that, the model is there, the structure is there, but we need the data and information how they will react when being mixed. The third aspect are the silvicultural guidelines and training plots, and in this case it's the same. Silvicultural guidelines, for example, for mix stand, they need information about different kind of mixing structures. So should there be individual tree mixtures, or will one species vanish after 5 years as the other is dominant? So how should we mix in terms of structure, or how do we mix in terms of time lag? So some mixtures, if one species come first and then 20 years afterwards or 30 years afterwards we come with the next species in order to design the mixture in a sustainable way. So there are also a lot of ideas existing and a lot of prescriptions already existing, but what is missing, that is data. That is still data, and we need more infrastructure to produce data for mixed species stands. Training plots are existing to spread the information to forest owners and to managers. And especially here yesterday we visited martelloscopes here now all over Europe. There are, sorry, I don't know, that is a little bit automatic here. These martelloscopes where you have such mixed species stands, and you have a digital twin of these mixed stands in the computer. So you can mark the trees in the stand, and then you put the tree numbers into the computer, and you can directly see what kind of effect does it has on productivity, on carbon stock, on biodiversity, on structure, to teach the people or to learn ourselves what is the cause and effect in such stands. So I summarize the second part. Mixing experiments needed, models available but lacking data for their parameterization, update of silvicultural prescriptions, training and teaching plots, especially these digital twins which we call martelloscopes, they are missing and needed. And the pity is that in the past we had a lot of data. We had of monospecific stands, and in the past the universities invested a lot of time and the research station in infrastructure. So now we are living from the substance of that what they did 60, 70 years ago. They established plots and now we use the data. And the big problem now is that we also now should establish new plots, but the universities often have the structure that there is no money there and no time, and the young people are not thinking of, I mean, I don't want to blame the young people, but there is a stress to publish and to create output, and there is a lack of money and time for building up new infrastructure. Fear a lot is that in 30 or 40 years they will tell our generation that we, not here, I know we visited a lot of plots yesterday, but they will tell our generation, it's very nice your output, but you did not think about the fundament for the future. You were exploiting what your founding fathers established very excellently with excellent computers, but you forgot to put money into infrastructure, and that is I think that would be very important to put money into infrastructure regarding new diverse forests to understand what is going on. The same way as now we analyze what is going on in enterprises, in schools when they mix different genders, different age classes, and they do in schools. So they invest a lot of energy into that. But in forest science, we also should do that. And the last part of that is what I mean by diversification. For example, in agriculture, they are in the same level presently. They are under pressure that they devastated with the Green Revolution. They devastated the landscape and had monocultures, and now they are in this phase that they try intensive mixtures with many species, with 2 or 3 species, with some species and trees. And in forest science, we have these examples. Sorry that that we mix 2 or 3 species. That is what I mean, for example, by diversification. And fortunately, and that is a big advantage compared. I have a couple of agricultural colleagues I work with very intensively with, that we can walk in our systems. So, for example, this year, that is a forest stand, and we can walk in this system without destroying this forest stand. We can walk, we can take laser scanners in, and we have the possibility to measure that stand very often in agriculture. If you enter, you destroy. I mean, you produce artifacts, but that are also plants, and they have the same mechanisms. They have nearly the same rules, the same growth rules, the same self-thinning rules. Many of our typical classical achievements in plant growth are the same in forests as in agriculture, but when they enter, they destroy. Or they would be a reduction in size by factor 100, like Alice in Wonderland, that you are little, and then a mouse is a monster, and you could enter and measure in the, but it is not possible. So that means in forests we can do that. And doing that in forests, we can, and that is, for example, what we inherited from our founding fathers, that we have forest stands where we record already the development of trees over 150 years. So they went in 1860, 1870, and measured all diameters, the height, height to the crown base, the positions, and then you see age 10, age 30, age 50, age 100, without destroying, as we are not like the agriculturists with these problems that you that you destroy when entering. And using such time series, we see that if we don't do anything, so if we don't manage, then there are Darwinistic forces, and they maximize the growth at the individual level. So some trees grow very, very much, and others lose. And per hectare, that is not the optimum. So, and when we homogenize, then we have finally very homogeneous stands, and the productivity is not the optimum. But if we structure and modify the structure in a way that we always have some small and some medium-sized and some tall trees, then we have an optimum. So that means that structuring can produce more growth than homogeneity or doing nothing. So that is a unimodal curve. Of course, here is the effect of the tree size variation. And here is the effect of density. Of course, if you have denser stands, they produce more. But even if you have the same density in a stand, and the stand is middle structured, the productivity is higher than a stand without any management, or a stand with permanent management where the structure is homogenized. We have the same data, but only very, very short time series from mixed stands. And then we see in these mixed stands, in some cases, for example, eucalypt or Pinus radiata, they are outperformer, and there simply the monospecific stand always grows more than the mixed stand, at least for one generation or 2 generations. And over 2, 3, 4 generations, the site index and the nutrients may be depleted and the productivity goes down. But over 1 generation, in many cases, but these outperforming species, like, for example, in Germany, we have this Douglas fir, it's difficult to beat with a mixture. But in most of the mixtures, we see that if you mix 1, 2, 3, 4 species, then the productivity increases. And that is a study, for example, I told that, I tried to say that we have a lack of mixed species experiments, and that is an evaluation based of inventory data worldwide, and there a group used the inventory data of 150 or 160 countries worldwide and analyzed the effect of the mixing, and that means on average, of course that is not always, but on average we see that we increase the tree species number, we have an increase in productivity. And of course the other services and functions I mentioned. And the background of this, so the mechanism behind this so far, that are the two main effects, I mean these phenomenons of competition reduction, that you mix two, for example, in case of two species, which are, for example, non-plastic and plastic, light demanding, shade tolerant, shallow, deep rooting, seasonal or evergreen, slow or fast growing, which have different niches and which somehow use the available resources or tap the available resources and use them in a better way, maybe by a complementarity in space or time, but simply the effect is that there can be in some cases a plus of 20 or 30, in other cases not, in other cases a minus of 5, but that is, and of course the other functions and services I mentioned, and that is one of the concept, this competition reduction, that in a team, it's the same at the university, in the team there is an excellent programmer and an excellent theoretical thinker and an excellent administrative person who is able to achieve the money from EU funding and so on, and the mixing is interesting. The mixing matters. I mean, not only the individual trait, and that is this complementarity idea. And the second mechanism, that is this facilitation, so that one species really pumps up, for example, some alkali, and the other species benefits from that by the litter fall, or there is hydraulic redistribution. For example, we have cases or examples in our country that oak in dry years transports water upwards and via the solum of the soil is transported to pine, or very classical example that are the nitrogen fixing species. We saw that in the DESA last week, that there is a nitrogen fixing species and the other species benefits from that. So the second principle is this facilitation principle. So I summarize the third part of my talk: competition reduction and facilitation need further research. So we know these symptoms and we know them from some species, but that needs more attention. Proportion between human and tree size enables insight into tree-tree interactions, so we can enter the stands, we can measure them, and we can use this available data by clever program code, I mean by spatial analysis, and knowledge of species-specific behavior is required for models, for parameterization of models, for planning, and for silvicultural guidelines. And I come to a perspective and a conclusion, and that is the most important part of the talk. And that is, I want to get again to this first, to these, we call that in Germany the Tüngen rings, created in the medieval times, that they said that is an urban area and people need their food, so that the gardens, the vegetable, and the rape field, the fields are close, and the forest is not used so intensively, so that is a little bit further away. So that is this typical segregation we created in the past, the Tüngen rings, and that was pushed even by the monospecific stand, by the monocultures, and also by the agricultural revolution, that they had used these pesticides and so on, and huge areas, and cutted the trees. So that is a segregation effect, and that had also the effect on the segregation at the faculties. So that means that was not only that in the landscape we have these different sectors, but also the agriculturists, the urban scientists and the forest scientists till today. I mean, what I talked about so far, that is only the diversification in the sector, so that we want to make the forest more diverse in terms to get it more productive and to get it more stable and more better for health and recreation, and to do the same maybe in the other sectors. But it is very important to and we saw that it is possible to increase the functioning here of this system forest, for example, by diversification. But it is important to notice that there is not only a forest, that there is not only a forest carbon or agricultural carbon or an urban carbon, but or a forest health or a forest agricultural diversity or an urban diversity, but that it is important to have a sector overarching diversification. Sector overarching diversification, and that is going on now slowly, that we create in forests also open areas or humid areas, and in the agricultural parts there are planted trees again. I mean, you have in many parts in Spain, that is no problem for you. You have these dehesas, but in Central Europe we cutted all these trees as they were disturbing the big machines, and now there are tendencies that, for example, in urban areas there are not monospecific alleys, but there are alleys which, if they are monospecific, the species simply, if there is a parasite, the whole alley vanishes. And there are examples for tiny forests or for urban food gardens, where in the city center of Copenhagen they establish urban food gardens where the people can go to and then and learn again a little bit what is agriculture, and that has also an effect on psychology, on aesthetics, on birds, on other animals. So I mean, it is important to realize that so far my talk was about this diversification in one sector, but the overarching diversification, that is for the faculties of, I see that in Munich, for example, that is a real challenge, and it has an immense potential, as so far often the agriculturalists, the urban scientists and the forest scientists see each other somehow as not enemy, but competitors for money, and on the long that will not work. I mean, on the long we have to somehow find some reconciliation of these sectors, as a segregation was done by humans, and it should also be repaired by humans in order to create maybe a better environment. Yeah. So thank you. That was all. But that was not all. The last slide, that is thanks for discussion and advice. So there were a lot of people here, and there were greening scientists involved in this thing and in our approach. And we just last week or 2 weeks, we published a paper about this. Miren is included, and Philippe about urban greening and diversification, and agro-scientists and plant biology and forest science. And from these different sectors, they all agreed. I mean, maybe that is trivial, but they all agreed that the cooperation is essential, and that so far we see each other as competitors. And there should be some changes. Yeah, but that was the last slide.